Ladies and gentlemen, the next speaker, the next presentation is going to be made by Mr. Rimas Karidis, Technical Director of Collerina Cobalt Limited. Mr. Karidis has over 20 years of experience in minerals exploration and resource development in gold, base metals and industrial minerals. Mr. Karidis led the geological field teams to the discovery of the Tomingley and McPhillamys gold deposits in New South Wales and steered the Hera Gold Lead Zinc project from discovery through to successful commissioning and commercial production. Mr. Karidis was previously founding Managing Director and CEO of ASX-listed Aurelia Metals. Please welcome Rimas to the stage.
Thanks very much, everybody. My pleasure to present Collerina Cobalt today. We'll be really focusing on high purity alumina in this project, so the name Collerina Cobalt is a little bit misleading, but hopefully by the end of the presentation you'll understand the reasons for that, where we've come from and why we're so focused on high purity alumina. I'll try and break the talk up into three parts. I'll introduce the company briefly. I'll have a section on high purity alumina as a sector, as I think it's not well understood. And then the last part I want to talk about HPA First, which is the company's strategy for bringing high purity alumina production to the market quickly. The company briefly, a market cap of around 60 million at the moment, a recently completed rights issue for $4 million, and that rights issue is to fund what we're calling the HPA First strategy through pre-feasibility study, through project piloting, all the way through to definitive fee study. Recent highlights of the business very much focused on this HPA angle, the adoption of what we call HPA First, the production of high purity alumina as of Monday, announced as per Monday using this new process, the completion of a rights issue to fund the next step with the pre-FS due October this year, and that we expect to roll directly into project piloting and definitive feasibility studies. A little bit on the company's background. Norm Seckold and Peter Nightingale are well-known industry veterans. Justin Werner, the company's managing director. Up to this point, myself as technical director. Justin and I will effectively swap roles later this month, with Justin taking a role full-time with the upcoming Nickel Mines IPO, and Tony Scrow, a chemical engineer. HPA First, to introduce it briefly, and then we'll revisit it at the back end. The company was looking to develop a nickel cobalt laterite and use a proprietary process technology to extract aluminium highly selectively and process that through to high purity alumina. And that process was well advanced in the feed study, and then we recognised a major opportunity to use an industrial chemical base rather than a laterite nickel cobalt acid feedstock. With this step forward, what we've effectively done is we've captured over 90% of the project revenue and reduced the capex by about 75% and the opex by around 30%. So it's just simply good business, and we retain an option on the nickel cobalt project as well. So I'll talk a little bit about how that came about and where it's leading us, but in simple terms, we've made a major process simplification. That's led to a major reduction in opex and capex, and it also provides an opportunity to bring this whole project to market much, much faster. We have a compressed feasibility, technical studies timeline, and a much compressed permitting process as well. A little bit now about high purity alumina, the market. High purity alumina is a very high purity form of aluminium oxide, and has effectively two dominant market uses. The first is in LED lights, and the second, and the real growth engine for the LED market, is in ceramic coatings on lithium-ion battery separators. I'll talk a bit more about that on the next slide. But it is particularly leveraged to EV growth, because EV batteries are sensitive to what's called thermal runaway, which is the process of a slow-moving oxidation reaction inside your battery becoming a fast-moving oxidation reaction. The process in batteries is called thermal runaway, which is a polite word for fire, and the requirement to have a high-quality separator in the batteries is critical for battery safety. But a little bit about how high purity alumina is priced. SGA is smelter grade alumina. That's the product that feeds the refining industry. So the product out of bauxite, that's about $400 a tonne. And for businesses able to produce a high purity product, particularly the 4.9s or the 99.99% pure product, there is 100 times value uplift through to a range between $25,000 and $50,000 per tonne. And that is absolutely, in basic terms, that's the value proposition for our business, is to take a smelter grade alumina product, but we're going to buy that product out of the chemicals market and use our proprietary process and run that through to a high-grade alumina final product. To break the market down in a bit more detail, it's effectively broken into two parts, powder and pellets. The pellet HBA goes through to sapphire glass, and that really is dominated by the LED market. But an increasing market is sapphire glass using a high-end, scratch-proof, high-end iPhones, mobile phones and smartwatches. But the powder market is perhaps the most exciting market. It's the market that feeds the lithium-ion battery separator market. And as I said, as safety becomes a key priority in high-temperature EV batteries, the use of gold standard ceramic-coated battery separators becomes critical to prevent, as I mentioned, the process of thermal runaway. On the demand side, the graph in the upper left really snapshots the market as of right now, and you can see the dominance of LEDs at over 50% of the market. But the two graphs at the bottom are from two different industry analysts. They both predict a growth in the high purity alumina market of about 18% through to a 125,000 tonne per annum market by 2025. Interestingly, they've both got a different growth engine. On the left, there is a LED driving the market growth, and on the right it's very much the lithium-ion battery separators driving the market growth. That tells us the market is reasonably impenetrable, given that there's a sort of bifurcation of analysts' view. But encouragingly, the potential there is for both of those markets to drive demand and drive it larger. The HBA in the current market is effectively manufactured from aluminium metal and retrograded down to a high purity alumina step. That process is high cost, and it obviously has all the inherited production costs of aluminium metal already. Notwithstanding that high cost, it operates at a very high margin already. So the high purity, I guess that's telling us the market is very well priced for new entrants. Our process is much more simple than that. It is basic solvent extraction. Solvent extraction is a process very familiar with the copper market. It's about a quarter of the world's production is produced from solvent extraction. For those not familiar, in simple terms, it's the mixture of an organic or an oil-based compound with an aqueous solution containing the target cations or the target metals. And that organic or that oil is specifically targeted to electrochemically bond to the target metals. And so you end up with a layered solution at the back end with the oil containing your loaded target metal sitting above the aqueous solution, and that allows you to separate that metal from the aqueous. And then in our step, there are two more proprietary processing steps through to high purity alumina. The reason this process works is the organic extraction is highly selective, and then so it generally comes out of the organic at about 99.8% pure, and then there's two more crystallisation steps which reject further impurities through to 4.9s HBA. So the benefit of this process is that it uses a very well-known process in solvent extraction, but specifically tailored for high purity alumina. The content of the organic is obviously highly confidential, and the two processing steps behind it are also highly confidential, and the value of our business fundamentally lies within maintaining that confidentiality. But importantly, they are wet chemistry atmospheric tests using standard industrial reagents. So there is, from that point of view, there's no market risk. This slide, I think, kind of summarises well where we came from and where we've got to. We were essentially looking at a relatively standard nickel cobalt laterite mining operation, mining a laterite, subjecting it to 2 stages of acid leach, filtering it, neutralising that, tailings dams, ... iron removal, and all of that to generate a pregnant liquor solution, which was loaded with aluminium, nickel, cobalt, scandium, and feeding that to first our HBA process to produce a HBA, and then the raffinate or or the underflow going through to a mixed hydroxide product. What we recognised through the test work is that we were spending an enormous amount of capital intensity and OPEX to generate a PLS that had a grade of about 5 grams per litre aluminium, and that aluminium was already available in the industrial chemicals market at about 1/4 of the cost, at about 50 grams per litre aluminium. So we get 1/4 of our process OPEX, and we cut out, at this stage, we cut out the whole mining operation. And we look purely to apply this process to the industrial chemicals market. So we call it HPA first because it allows us to build a high purity alumina refinery in a location of our choice. And at this stage, it looks like Newcastle, and it maintains an option on the nickel cobalt operation that we're able to back end and build at a later date. And the refinery will just plug into that process. So hence HPA first. In geographic terms, if I was to represent that, this is what the project looked like 6 weeks ago. A mine in Western New South Wales, an acid leach and an SX plant in central New South Wales around Narromine, and an HPA refinery in Newcastle. But all our CapEx was in the nickel cobalt laterite, and 90% of our revenue was in the HPA. So by adopting HPA first, what it allows us to do is to capture all our dominant revenue and reduce our CapEx by circa 75%. So it's a far more attractive business case in the first instance, and absolutely compelling from market valuation point of view. It's difficult so far for the market to value what this business is worth, and we understand that won't really occur on a financial basis until October this year when we publish a feasibility study. But in the meantime, we are targeting a PFS that is targeting a production level of 10,000 tonnes per year of HPA, priced somewhere between $25,000 and $50,000 per tonne. So our revenue line should look somewhere between 250 and 500 million US per annum. Our margins will be available to us for the first time in October. When we compare what we're doing to other proponents in the market, there are other HPA proponents. Probably the most high profile is Altec, who I think have done a fantastic job in market education and are actually more advanced than our company is. But we are fundamentally different insofar as our feedstock, as I mentioned, is an aluminium chemicals market. The aluminium chemicals market is deep and global. It feeds the water treatment process globally, so there are over 220 different factories from which we can buy our feedstock globally. And the alternative proponents are looking at a kaolin feedstock, and the reason why that is where all the value change is that kaolin feedstock is a silicate bond, and anyone with a nickel cobalt laterite understands that when you're trying to free a metal from a silicate bond, you need an enormous amount of chemical energy to do that, and immediately you're looking at a high capital intensity for your project. By completely flipping that paradigm and having the opportunity to use a technology that allows us to pull aluminium from a solution, we're able to completely sidestep the idea of separating our target metal from a silicate bond, and we can buy it, as I said, in chemical form. This allows our process to be highly simplified on a comparative basis. We effectively have 2 steps: solvent extraction and HPA refinery. So we think that when our capital figures land and when our business case lands, it will be absolutely compelling. It will be in a different risk universe to our peers, and we think our operating margins will be at the very lowest end of the HPA market cost curve. A couple of milestones. Since we adopted HPA first only 6 weeks ago, we've already run our first mini rig run, which is effectively a scaled down SX pilot plant, and successfully produced our first high purity alumina. I know we've only got an hour or 2 left in the booths, but we do have a couple of canisters of white powder, which none of the brokers have spotted so far, so it's still there. And if you guys want to come and have a look at that, it can be touched and felt and validated. We've got a second HPA run due in the next 6 weeks, which will be a much larger volume, kilogram scale HPA, and that will be the product that we interact with our off-takers with. And all of that feeds into a PFS due for delivery, as I mentioned, in October, and that will roll directly into a pilot plant. Our pilot plant planning is underway. We're buying equipment right now, and we expect, ultimately we'll be running a 8 kilogram per day pilot plant for about 6 weeks. And there's already discussion about our pilot plant being a net cost neutral process given the value of what we're producing. So revisiting, I guess, the HPA first concept at the back end of the presentation. I hope I've demonstrated what a major process simplification HPA first is. I hope I've demonstrated, the compelling nature of the HPA market and how well it is leveraged to not only the technology space but the EV space in particular, and how it's well placed for new entrants like Collerina. We're very fortunate to have access to this very unique and very clever technology which allows us to commercialise HPA first, to sidestep the traditional technology steps and feasibility steps that a mining company would normally face, that we can remove our mining risk and fast track the whole project, both on a technical term and also on a permitting basis. We can fast track through to HPA. Thanks very much.
Are there any questions for Remus? No?
Right.